talk about the main idea of this new type of databases, object-oriented databases. So the main idea, store objects directly in database. So what is this idea? First, I like to say this idea, it is a academic project first. So many successful business projects initially came from academia. So in college, universities, many researchers, so they start some research projects first. After the projects became very successful, or people see some very promising potential, so then they move to the business world. So this approach very common. For example, relational database. So you can look at the relational DBMS. So that initially it was an academic project. And SQL query language, initially also academic project. And then later moved to the business world, very successful. Okay? So here, this one is another one, this object-oriented. So it's academic project. Okay? But some of the projects may not be successful. This one is not successful. Okay? Object-oriented databases, we can say it's a failure. This project, it's a failure. So first, let me talk about the idea. Researchers, so they try to, based on their logic, initially, they create a project based on their logic. But we know many times the logic may not match the real world reality. Because your logic, other people, business people, they do not like your idea. That happened a lot. This one is one. So what's the main idea? From the name, you can see object-oriented database. Object-oriented programming is very successful, right? That idea is very successful, object-oriented. But object-oriented databases, it's a failure. So why is that? Let's look at the main idea. So the main idea is store programming objects into databases directly. So that's the main idea. Okay? Main idea, store programming object. Programming object, right? Programming objects into databases directly, not indirectly. Okay? That's the main idea. Programming objects. So we know in Java, in C++, object-oriented programming languages, we can define classes. Then we can use classes to create objects. And we can use objects to store our data, store our structured data. Okay? That's the main idea, using objects. Or one of the main usages using programming objects. Okay? Yeah, yeah, yeah. But those researchers, they want to store the objects, data, structured data inside objects into databases directly. Yeah. We know objects correspond to binary data. Okay? Yeah. Programming objects. Yeah. Programming objects basically correspond to binary data, not text data, right? Binary data. Yeah. The binary data. Yeah. So when you store the binary data into databases, not readable, right? It's not readable. Okay? So you cannot use some software tool, open it up, then you can view your data, right? Because it's a binary format. How do you view your binary format, right? Yeah, yeah. Yeah. But why those researchers, they still want to do in that way? So they feel because some of the data, structured data, could be very complex. Yeah. If you do not store objects directly into databases, you need to do conversion. You need to retrieve data from the objects, then write the data pieces in a different way into tables. Yeah. There is a conversion step. Yeah. All right. And the other way, after you retrieve data from the table, you need to, write it back to certain programming objects, then use those objects in your projects. Okay? So that kind of conversion, so those researchers, they feel not convenient, not efficient. So they want to do it more efficiently, right? So they want to skip the conversion step. Yeah. Just write objects directly into database, then retrieve from database, then use it directly in your projects. Yeah. So that's their idea. Yeah. So here you can see doing that, there is no object relation conversion. Yeah. Relation, yeah, so that's our SQL structure. Yeah. Object programming structure. They have different structures. So usually there should be some conversion between them. Yeah. But this idea, so they want to bypass that conversion. Yeah. All right. So then, when they try to, sell this idea to the business world, nobody bought it. Yeah. Yeah. Nobody in the business world liked this idea. Okay. Yeah. Yeah, because, not very convenient. Yeah. People in the business world, people want to view their data frequently. Okay? Yeah. So they like their data stored in mainly text format, not binary format. Yeah, text format, people can manually work on text data, right? Yeah. If it's a binary, then so you may need to develop some viewing tools. Yeah. If you really want to view your data, you have to rely on some special tools. Yeah. All right. Yeah. So then, yeah, just like the result have not found widespread use. Yeah. Actually, not widespread. So almost no use. Yeah, almost no use. Okay? Yeah. All right. But why we still talk about this idea here, right? If it's useless, why we can skip it, right? Yeah. The reason we still talk about this idea here, because this idea, although not successful, but it inspires another idea that is successful. Okay? Yeah. So another idea try to solve this problem, binary data problem. Yeah. Yeah. So that idea, you can still maintain your data in text format. Yeah. Business people like the text format. Yeah. So you do not change that part. Yeah. But still you achieve part of the goals that object-oriented databases want to do. Part of, not 100%. So what's that? Object relation conversion. Object relation mapping. Yeah. So people, mapping. Okay, mapping. Yeah. Yeah. Conversion related to that mapping. Yeah. So let me talk about that inspired idea. Okay, successful. Right now, very popular in the business world. So I talk about that one. Yeah. All right. Okay. That one called Object Relation Mapping Solution, ORM. Yeah. People use ORM refer to this technology. Okay. Yeah. Mapping. Yeah. Yeah. The original idea tried to bypass the mapping step. There is no mapping step. Okay? Just store directly. But now, because in order to keep the text data format, the business data is always stored in text format, then some mapping step should be used. Yeah. All right, so object relation conversion is done by the ORM tool automatically. So there is an ORM tool created, mapping tool created to do that conversion. Yeah. We as programmers, we do not need to do that conversion. The reason is that conversion is tedious. The conversion work, tedious. Yeah, especially you can think about if there are a large number of tables. Yeah. When you want to convert between objects and a table format, you need to do a lot of work. Programmers, you need to do a lot of work. And many times you may have many errors. Human errors, right? Yeah. But this ORM tool does the automatic conversion. It can minimize the error. Yeah. Yeah. Minimize the errors. And conversion is very fast. Conversion, when you run the tool, just a few seconds, you can convert, let's say, hundreds of tables, yeah, to classes or classes to tables. Yeah, just a few seconds, you can do that conversion. Okay? Yeah. ORM tool. Yeah. So, what is that ORM tool? Yeah. Here, yeah, I can talk about one in Java. One ORM, one popular ORM tool. Yeah. It's a older technology, yeah, called Hibernate, Java framework. Hibernate. Yeah. There are many, other than Hibernate, there are many other, Java frameworks doing the ORM tool. Yeah. Yeah. And in Java, this kind of mapping right now so popular. Very, very popular. And you will see the current way to do that. The current way to do that, ORM mapping by annotations. Okay? Yeah. Annotations in your Java code, you use this @ sign. Yeah, @ sign. After that, you have some, special annotation tag. Okay. So you tell that tool, ORL mapping tool, what do you like to do? Yeah. So you put several annotation tags to tell the tool. So what do you want to do? So then the mapping is automatic. Okay? Yeah. So here, just to give you the basic idea. So you may see a lot of Java code used in industry doing this kind of work. All right. So here, I just give you the simple introduction. Let you know this basic idea. This slide, let me describe the ORM. How does this technology work? The typical steps. All right. Change the object relation mapping approach to this one. Okay? Yeah. So drop, the older approach. So no object relation conversion, right? That old object-oriented DB, that one, there is no object relation conversion. But this one, you do that conversion, but in an automatic way, not a manual way. Buy some special tool to do it. All right. So drop manual object relation conversion. If you do not use any tool, you need to do the manual conversion. So before this ORM tools were available, people just, the programmers write the code to do the conversion. So not efficient. Takes a lot of time to write the code, conversion code. So that's the manual way. Okay? Adopt this automatic object relation conversion. But you need to set up. You need to find a way to establish the mapping connection. Okay? The mapping connection, programmers, that's your job, responsibility to establish that one-to-one mapping. Okay? Yeah. How to do that? Yeah. All right. So here, when we use certain Java framework mapping tool, like Hibernate is just one of them. Okay? There are several other mapping tools. When you do that, a few ways. How it works. There are a few ways. All right. Old way, initially, old way, at the beginning, people use this way. Set up a configuration file. Because you need to tell the tool how to do the mapping. So you need to use a configuration file to do some connection. In configuration file, you need to tell how to connect to the database first, right? First connect to the database. After that, you need to specify the locations of the mapping file. There are many mapping files. Where to find those mapping files? You need to specify the locations. Okay? The database connection info and the locations of the mapping files. All right. So the mapping files, typically XML file. Yeah, because here, the old way, people use XML files a lot. Okay? Yeah. All right. And another way, simpler than XML file, that's the Java properties file. The text file, each line is one property. Yeah. So that's the Java properties file. Also can be used for mapping, but that way, not very popular. Yeah. XML file, the old way, it's a popular way. Yeah. Yeah. All right. Yeah. Yeah. So the mapping file, one mapping file corresponds to one table. One-to-one mapping. Okay, one-to-one mapping. Yeah. Yeah. All right. Yeah. So you need to have that, but those mapping files, you do not need to type those files manually. You can use another special tool to generate the mapping files automatically. Okay. Otherwise, if you type, you need to do a lot of work. Still not efficient. Okay? So you rely on another special tool to generate those mapping files from your database. You have a database first. Okay? Then the mapping tool connects to your database, you go through all your tables, then generate XML mapping files from your tables automatically. That's the old way. Okay? That way. Yeah. And the definitions of mapping objects. So that's the, here I use Java. That's the Java classes. So what's the definition of mapping object? So Java classes. Okay? Yeah. These Java classes, people call, entity classes. Entity classes. Yeah. Can be generated automatically. Yeah. Also, generated automatically. Yeah. Otherwise, takes a lot of time to create those classes. Yeah. So you can see a lot of files you can generate using some tools automatically. Okay? Yeah. All the supporting files are generated automatically. Okay? Yeah. But these ways, still, that's the old way. Okay? Old way. All right. New way, as I mentioned before, using annotations. Okay? Using annotations, yeah, then all those generated files are hidden. You cannot see. Okay? Yeah. You only have the annotation code. Other than the annotation code, all other related files are hidden. Yeah. So you cannot see the physical files. Yeah. Those supporting files may be generated internally. So you cannot see those physical files internally. Yeah. But what you can work on, just the annotations. Yeah. So that's the, the current way. Yeah. Current way, people use annotations to do a lot of work. Yeah. So you will see, when you work in the business, so you do more and more work using annotations. Yeah. All different things, you use annotations. Yeah. quite a lot. Yeah. Okay, all right. So that's this topic. Yeah. So I just give you a brief introduction. So let you have idea in your mind, because when you work in industry, you have a very good chance to see this technology. Yeah. Yeah. So if you have the little understanding, yeah, at least you can get you started. Yeah. So you know, oh, this technology is used. Yeah. So then you can, study some technical articles to learn more details. Yeah. All right. Yeah. Now let's move to our part D of Module 2, last part of Module 2. So we will finish, after today's class, we will finish Module 2, okay? Yeah. So then this weekend I will give you homework assignment number 1, okay? Covering Module 1 and Module 2, 2 modules, okay? Yeah. All right, so let me go to the last part. Yeah. Part D, yeah, here, yeah. All right. All right, yeah. Some more database concepts, yeah, we have a few more important concepts. Yeah. 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 D.1, virtual tables. Yeah. Virtual. We just learned normal tables, physical tables. Now, the tables, when we talk about tables, they are physical tables. Yeah. So what are the physical tables? The data of the tables will be stored into databases physically as a physical files. Virtual, you know the meaning. Yeah. Virtual means not physical, in a virtual way. Okay? Virtual way. Yeah. All right. So let's look at this concept. View of a database. Here, the term view has a special meaning. Yeah. Has a special meaning. Yeah. 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 We know the view, if it's not in the database context, if not in the database context, the view, we view something, yeah, some special display way, that view. Yeah. But here, the view in database has another special meaning. That's the virtual table. Okay? Virtual table. Yeah. Yeah. Why we call it view? Because the virtual table is closely related to the view. Okay? A specific view of the data. Okay? Yeah. But actually it's a virtual table. It's not a physical table. Yeah. Yeah. So connects to that original view meaning, yeah, but it has its own special meaning. Yeah. All right. Why we need it? Yeah. Why we need this concept, view? Yeah. In the business world, it is useful. Yeah. All right. Different users may require different perspectives on the same set of data. Okay? Yeah. When you have large group of users in the business world, large group of users, yeah. Your original data, so you stored your original data into several tables, yeah, into many tables, yeah. But you have a large number of users, large number of business users, your customers. Yeah. All those customers, they like to view the data in different format, yeah, based on their own businesses. Yeah. So the data should be presented in their own preferred formats. Okay? Yeah. But you don't want to, so for each customer's preference, you don't want to create a physical table to store that data, right? If you do in that way, then you need to use too many physical tables. Okay? For example, your original data, you just have dozens of tables, but you have a large number of customers, so they would like to view their business data in so many different ways. You may need to create hundreds of, thousands of, even millions of different views. Do you want to all store as physical tables? No. Okay? Yeah, in general, you don't want to do in that inefficient way. So, more efficient way, you create virtual tables. Yeah. Virtual tables, you do not store the data corresponding to their views physically on your hard drive. Okay? Yeah. Yeah. Virtually, yeah. So the DBMS knows how to display the data in virtual format. Okay? Yeah. Yeah. So first, it saves storage space, but the more important, it simplifies the complexity of your databases. Complexity. Okay? Yeah. Just the views. Yeah. All right. Yeah. So here you can see from the business world reality, yeah, this concept is useful. Okay? Yeah. All right. Next. Yeah. An efficient way handling data. Yeah. Yeah. The virtual. So here, let's look at the situation. A virtual table. A virtual table, or we can say yeah, because it's derived data, right? So it may rely on multiple tables, yeah, not a single table, okay? Yeah, yeah. Multiple tables, physical tables, yeah. All right, yeah. And you only need to store its definition. All right? You only need to store definition of the view. Okay? That's all you need. Yeah? You do not need to store the derived data. Okay? Yeah. Yeah. So here, so what do? You do not store the derived data in general. Okay? Yeah. So here I say in general. Yeah. So by default, you do not store the derived data. Yeah. But if you have good reason, you can store the derived data. Yeah. So certain views, they are extremely important. So you like to store the data corresponding those views physically on your hard drive, so then you can do it. But in general, so if you do not have good reason, then you do not store the physical data. Okay? Yeah. So that's the typical way. Yeah. Dealing with those views. Yeah. So that's why we call it virtual data. Yeah. Because by default, not physical. Yeah. In special situations, you can make any of them physical. Yeah. No physical storage for the data derived from physical data. Yeah. But every time, in order to display the data for one particular view, you need to run the definition of the view to generate the data. Definition of the view. Okay? Yeah? Yeah. All right. And a save storage space. Yeah. So, yeah. Yeah. So this concept, yeah. So, you know, is useful, yeah, from the business world. Could be stored physically if needed. Yeah. Yeah. All right. Yeah. Yeah. The view. Yeah. So there you may want to know, you know, how to write a view specifically. Yeah. So here, because view is a virtual table, so here we just compare view and table directly. Okay. Yeah. Because one physical, one virtual. Structurally, the same structure. So the same structure. Yeah, structure. Same structure. Yeah. Yeah. Only difference when you write a definition. Okay. Yeah. Definition. When you compare the definition. Only difference is view versus table. Okay? Yeah. Yeah. For the virtual table, you just create view something. Okay? Yeah. So for the view, you create a view. Create view there something. Okay? Yeah. For table, you create table remaining when you describe the structure in the view in the table exactly the same. Yeah. Only difference is this word difference. One you use view, another you use table. That's the difference. Okay? Yeah? Yeah. Yeah. So it is very easy. Yeah. Yeah. All right. Yeah. Then, next, size of a database. Yeah. So let's look at this concept, size. Yeah. General, a database can be of any size and complexity. Yeah. That means no limit for the size. No limit. Okay? Yeah? Yeah. Some of the databases in the business world could be very large. Okay? Yeah. Several gigabytes, many gigabytes. Yeah. So now, the big data even, terabytes, right? Yeah. Huge, TB, yeah. All possible. Okay? Yeah? Yeah. All right. DBS may have restriction. Yeah. DBMS, yeah. But we know for DBMS, some DBMs can work on arbitrary data sizes, but some, relatively small DBMS, so they, put a limit on the data sizes. Yeah. Here, for example, MySQL, Oracle, no limit. Yeah. But for Microsoft Access, now Microsoft Access, yeah, there is a limit. Okay, yeah, here 2 GB. Yeah, so that probably some old number. New number could be a little larger, but still a limit. Okay, because the target of Microsoft Access for small business, yeah, even personal business, even very small or personal business. Yeah. If the business is a little larger, then they do not try to target that group of people. Yeah. Yeah. All right. Understanding query. Yeah. This query, this word, the meaning. Yeah. So here we use query word a lot. Yeah. So here there are two different types of meaning. Yeah. In database context, people understand these two different ways. One in narrow sense, the query, its meaning. When you do the query, so you do data retrieval, the narrow sense. Yeah. When we retrieve data, so we call it query, but it's a narrow sense, not a broader sense. Broader sense, any database access, including modifying data, all those operations we can call query. Okay, yeah, all of those we can call query. Yeah, yeah. All right. Yeah. Okay. Yeah. So that's the the D.1. Yeah. Yeah. All right. Then next, yeah. So I want to talk about yeah. So yeah. I will change the date. Yeah. So to yeah. All right. Yeah. All right. Yeah. More on stored procedure. Here, I like to give you a little more information about stored procedures. Yeah. Yeah. All right. Situations. Yeah. So here, I like to expand it. Yeah, we learned this concept before, yeah, but here I like to talk about the main usages of this technique. Yeah. Under what situations we should use stored procedures to improve our overall efficiency. Yeah. All right. Look at the situation. Yeah. Resources are distributed on different machines. Yeah. So here we consider some relatively large business running in the world. Okay? Yeah. So we consider a large web application. Yeah. So let's imagine a large web application. Okay, how large it is? Yeah. So the whole web application takes the distributed way. Yeah. So we call it distributed web application. Yeah. Right now, it is very common in the business world. Okay. So it's not your whole web application is running in a single location on the servers. Yeah. In many, so one circle represents one location. Okay. Yeah. One place in the world. Okay. All right. Many different countries, different cities. Yeah. each location, you have many servers, running part of the web application. Yeah. All right, yeah? So, all right. And you may have some data center. Yeah. So here, let's suppose this is the, data center. Okay, yeah. All right. But they all need to connect to the data center. Okay, all right. Yeah. And each, they, between, they also need to connect. Okay, so the resources, all the resources are shared, yeah, among, all these servers. Yeah. So that's the typical structure for large web application running in the world, has this kind of basic architecture. Yeah. All right. In this situation, yeah. So now, this distributed type. Yeah. So let's look at how do we provide data services efficiently. Yeah. All right. Web application programs are on a web server. Yeah. All right. DBMS running on database server. Okay. Yeah. All right. An efficient way, database program module. Yeah. Here. So let's consider one specific data service. One specific data service. Okay. Yeah. Some data service. Okay? Yeah. Very special, very important. Yeah. You need to run in your database server. Okay? Yeah. All right. Then you have many different ways to do data services, right? Yeah. One way you can use stored procedure to do. Another, you can also use application programs to do, right? Yeah. Yeah. Application programs, you can do data services. You can implement data services. Yeah. But data services in the data server, you use SQL to write a stored procedure. Okay? Yeah. SQL, stored procedure. SQL way. Okay? Stored procedure. Yeah. Application programs, so you use your programming languages, yeah, and SQL included in your code to do the data services. Yeah. So there are two different ways. Here we like to compare these two different ways. All right? Yeah. All right. Yeah. Here, before I do the comparison, yeah, first let me talk about the stored procedure. I mentioned a little bit last time. Yeah. Here I say again, the stored procedure, there are these two ways. Yeah. The first way, we use procedures. We just use the procedure word to define our SQL function. Okay? This way, no explicit output. Yeah. Just like our void function, right? When we use void function, there is no output. So we only do data processing. We do not generate output. So that's for the procedure. But for the function case, there is return data, so there is output. Yeah. So in stored procedure, these two types separated. Yeah. Procedure and the function. Yeah. Later, I show you the code example, yeah. The definition, code example. Yeah. Just the main format. I do not show you all the details. Yeah. Just the external format. Yeah. All right. Properties. Yeah. So now we like to do comparisons. Yeah. As I mentioned, when we do data services, there are two different ways. One, stored procedure SQL way. Another, programming language implementation way. These two different ways. Yeah. Here I can do comparison a little bit. Yeah. Stored and executed by DBMS in the database server. So for stored procedure, you do it in this way. Okay? Yeah. So the stored procedure, so you do stored, executed by DBMS at a database server. Yeah. Naturally. Yeah. All right. And the other way, application programming way, so here. Yeah, all right. Yeah. So here, not the other way. Here, yeah, we still talk about the stored procedure. Created, we can, so here, this is a can. We can create it in DBMS or in application program. Yeah, DBMS, that's the direct way. Application programs, we need to write SQL commands. Okay, SQL commands. Yeah. All right. Yeah. These two ways to create stored procedures. Yeah. Called in application programs. Yeah. Definitely you can also call in DBMS. Yeah. You can call in DBMS. Yeah, but here, we can do remote calls. Yeah. Very convenient. Remote calls. Yeah. So you call remotely, but these stored procedures are executed in DBMS. Yeah. All right. Then we can compare their efficiencies. Yeah. Efficiency, performance, response time. Yeah. Yeah. Next slide, let's discuss the data service response time. Okay, yeah, so let's do the comparison. Okay, circumstances using stored procedures. Yeah, all right. Typical cases. Yeah. In these cases, why we can save response time. Yeah, all right. A database program is needed for several applications. Yeah, think about. So here, I need to draw that diagram another time. Okay? Yeah, several locations. Yeah, several locations. Yeah. Then in the middle, the data center, right? Big data center. Okay, powerful. Support for data services. Yeah. All right. Yeah. All right. So, yeah, like that. Okay. All right. So a database program is needed for several applications. That's common. Yeah. 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 Because so many different servers, so many different applications, they need to call the same database program. Yeah, that's possible. Okay, the several applications, could be in different programming languages. Yeah, think about that. Programming languages. That's also very, very common. Okay? Yeah. Yeah. So in your one big Java application, not Java, web application, okay? Some places, some location in the world, you use Java. Some locations, you use PHP. For some locations, you use C#. And some locations, you use, other Python, other programming languages. That's all possible. Okay? Yeah. 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 So many different programming languages, they provide different business services for the customers in the world. Yeah? So that's quite common in current business world. Okay? Yeah. So here the question is, for all those different programming languages, when you need to call the same data service, which way is more efficient? Which way is more efficient? Yeah. Here I'm talking about the comparison between SQL way and application programming way. Yeah. So here we compare two ways. One is the SQL way, that's stored procedure. Okay? SQL way, we know it means the stored procedure. Okay? Stored procedure. All right. Then application way, we mean in high-level programming languages. Okay? Could be Java, PHP, C#, Python, C++, and so on. Okay? Yeah. 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 Because for one specific business task, one particular language may have its own advantage. Yeah, one particular task, right? For example, Python, there is some AI-related tasks. Then Python has its advantage. How about that? There are some data science-related tasks, statistic-related tasks. So Python has its advantage, right? Yeah. But there are some general web-related tasks. Then Java has its advantage, right? Yeah. So that's the reason why people use so many different programming languages in the world in the same large web application. Yeah. Because they want to do so many different things in the world. Okay? Yeah, all right. In that situation, imagine this time when some of the data-intensive services, it's better you use SQL way to do it. SQL way better than application way for certain data-intensive services. Yeah. Why? Here, I explain why. For that situation, SQL way has its advantages. Because SQL way, think about, you only need to implement once in your data server. Only once. Okay? Then all other programming languages, they just call the same SQL procedure to get a service. Okay? All right. But if you just want to use application programs to implement that data-intensive services, yeah, you can do it. Do you need a Java implementation? Do you need a PHP implementation? Do you need a C# implementation? Do you need a C++ implementation? Do you need a Python implementation? So that's why we say not efficient, right? So many different implementations. Basically the same thing, right? The same data service. Why you need so many different implementations, right? So we just use one single SQL implementation running in our database servers. When people need to use just remote call, right? We do remote call. We send a call, procedure A, B, C, D. That's all you need to do, okay? So when you switch from one programming language to another one, it's easy, okay? Yeah? You call the same remote stored procedure. Yeah. So that's one big advantage, okay? So here I give you one situation about the big advantage using stored procedures. Yeah. Another big advantage. Yeah, so here, different programming languages. Reduce duplication effort. Yeah. What I just talked about, we reduce the duplication of effort because we only write one version, SQL version. Okay? For other programming languages, we do not write. Okay? So the advantage, it's called a reduced duplication of effort. There is another big advantage. Let me explain. Another also important advantage. That's here, improve software modularity. Yeah, so that's from the structure, from the architecture, maintenance. Yeah, so that's another advantage. Software modularity. Modularity. Yeah, but this is a big one. Yeah. I want to talk about this one. Reduce data transfer and communication costs. This is another big advantage. Data transfer and communication, there is a cost. Yeah, so let me explain this idea. Yeah. All right, so let me see what else do I have. Yeah. All right, yeah. So here, why we can reduce the data transfer communication cost? Because we do not need to send intermediate data between web servers. Think about if you use application programs to write, your database still stored in the remote databases, right? Yeah. Yeah. So the databases you still, because you still use the remote large data center to store the data. Okay? Yeah. Now think about if you use application programs to write data-intensive service code, do you need to do a lot of intermediate data transfer? Yeah. Because you need to do a lot of queries, right? Every time when you do queries, you send a query to the remote database server, the database server sends you back the query result, then you do some processing work, then you send another query, then query back, processing. Then you have a lot of communication, right? Yeah? The communication takes time. And there is a communication cost. Okay? Yeah. But if you use the SQL to do the data-intensive service just right at the database server, then you do not need to send the data back and forth, right? Only at the same location, you complete all the data-related processing services in that server location, remote database server location. Then you send the final result back. Then all the intermediate data transfer, you all saved. You all eliminate the intermediate data transfer. That's a lot of traffic, a lot of internet traffic. Yeah. So you improve the overall performance. Yeah. So that's another big advantage. Okay. Yeah. All right. Access data without giving out too much permission. Yeah. So that's another another advantage. Yeah. Think about. Yeah. Sometimes some tables may have some high-level credential information you don't want to expose to general programmers, right? Yeah, that's another reason to use store procedure. But some people, they have access to that higher-level credential data. They wrote stored procedures in an aggregate way, okay? In aggregate format way, yeah. Then other people, you do not need to have the access permission. You just call, store the procedure, you can get a final result. Yeah, so that's another, although relatively small advantage. Yeah. Two big advantages and several small advantages. Okay, yeah. So here, the first big advantage is this one. Okay, yeah, you know, multiple different programming language. Another is this one. Okay, these two biggest advantages. Other, you know, small advantages. Yeah. All right. Yeah, yeah. So that's the users may need aggregate. Yeah. So aggregate information. So you to avoid some, you know, high sensitive information exposed to people who do not have the privilege to access the data. Yeah. Yeah. All right. Then at the end, just 2 minutes, let me show you the format of to store the procedure. Okay, so we finished this part. Yeah. The general form of declaring store the procedure. The first one, the void type, without output. Yeah. We use this way. Yeah. Look at the typical format. Create procedure. Then you need to give a procedure name, just like a function name. Because when you call it, you need to refer to the procedure name. Then input parameters, you need to pass input parameters, right? Then local declaration, here you can see there is no return type. Yeah. That's the first type. Second type, declaring function, you need to return your output data, so you need to choose this function way. Okay? Create function name, then input parameters, then you specify return type. Okay? The output. Yeah. So then local declaration and a function body. Okay? Yeah. So you use SQL to write a function body. Yeah. 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 Similar to how you write ordinary functions. Yeah. The logic, you know, the idea, the way, you know, pretty much the same, just the syntax different. So you use the SQL syntax. Okay? Yeah. Yeah. All right. So after, you know, these basic introductions to give you the, you know, basic information about the how people use databases in the business world. Yeah. So although we talk abstract way, we may, for these things, we do not have chance to practice. Yeah. So, yeah. Mainly we practice on the SQL queries. That's the part we do practice, SQL queries. Yeah. For other concepts, yeah, you know, we do not have time to practice. Yeah. Yeah. All right, so let me stop right here.